welcome to the second block of IDEA StatiCa Global User Day 2023. We call the Voice of the Customer. So we invited 3 of our customers to join us in Brno and mix them up with one of our colleagues to talk about the experience with IDEA StatiCa. So allow me to introduce them to you. Wojciech Chalupa.
Hello.
So what do you do, Wojciech?
I'm the Chief Product Officer with IDEA StatiCa, meaning that I'm the one ultimately responsible for what we do and why we do it for you.
Thank you. Got Eline Vanthournout. Hello.
Hi, hello. I'm a project engineer at SBE. I work at the steel department and I mainly focus on bridges and industrial buildings.
Thank you. Harri Seibert from Germany. Hello.
Hello. I'm the CEO of a civil engineering company in Germany with roots in structural engineering, and we are now focusing for special projects and for standard projects in the industry, basically.
Thank you. And Tomas Pacik, hello.
Hello, I'm Tomas Pacik. I'm working for MacDonald company in the Czech Republic. I'm a bridge designer with over 15 years experience with the design of all types of bridges in different countries.
Perfect. I will now ask Harri and Tomas to share us their use of IDEA StatiCa. Let's get into the first presentation of this block.
So this is a short introduction for our company. We are located with headquarters in Bochum, and we have also subsidiaries in Paris and Mumbai and India. And we are working on different fields. Basically, it's a civil engineering services with a root in structural. We are doing project management. We are doing digitalization. We are doing this since around 35 years now, and of course we are doing consultant engineers. What I'm showing here is a project what we are currently doing in France. It's an extension of the train station in Nice, and it's a complex project provided by the architect Daniel Liebeskind. And we see it's under construction now. It should be finished by end of this year. And the steel structure in the model, we built this in a Tekla model, is shown also in the center. And on the right, we see how we come to the design of the complex nodes which are in that structure. So first there was a sketch by hand, just analyzing, okay, how could this be done? And after that, we built this in Tekla, that the structural engineer can understand, okay, how these complex connections can go. You see there are tube connections and there are I-beam connections, so it's a challenging joint. And we had in this type of project around 600 of these complex joints. And on the right side, we can see how it has been analyzed in IDEA StatiCa. So this model has been directly derived from the Tekla structures to that model, and it was running perfect. So we were not able to do it in a different way, because to justify that such a complex model is working, you need to have a tool like IDEA StatiCa. So what is our experience with IDEA? Especially for this type of special project, we got a quick feedback by the team, because of course the special node was not really implemented as the first step. We need to learn something, and then we could implement this complex geometry quite quickly. Of course, there is also troubleshooting, but the answers are coming very quickly to us, and this is why we are using this. And we are not using templates a lot, but for this special project, but for similar project, of course, we can also use the templates. For improvement process, we like and need adaptation for the complex geometry more and more because we are specialized for doing analysis in these complex geometry projects. And we need also fixing of bugs because if we drive the system to the limits, we need also to get the bug fixing. And we are looking forward to increase the usage of IDEA with or for connections with thin plates with less than 3 millimeter in thickness, and also for steel concrete connections where we have composite with compression, bending moment, and tension. This is basically our what we are looking for because the complex geometry is our daily work. So this is, I'm closing this short presentation, and thank you for this. I hand over to...
Hello, I'm Tomas. I'm from MacDonald company in the Czech Republic, office Brno. We are dealing with the design of bridges of all types and in different countries. My role in my team is mostly static and dynamic analysis of the structures. We have experience with the design of bridges, civil structures in all levels of design. And on the picture you can see the bridges which has been assessed and verified in IDEA StatiCa. It was very useful for us. So on the left picture you can see the suspended foot bridge in Pacik in the Czech Republic. The architect design has been has been done by famous architect Josef Pleskot. On the second picture you can see the arch bridge which has been built in Bergen in Norway. Our profession is sometimes very stressful, lot of communication, coordination and responsibility, and little time for the most important matter, and this is the safe and economical design. The IDEA StatiCa help us to design and verify the structures in the short time without the need to study manuals due to its friendly interface and easy to use. We are trying to use all products of IDEA StatiCa in order to leave more time for engineer works. On the picture below you can see the Matagaru bridge. This is the foot bridge in Perth in Australia. We did there the category 3 check, and for the verification we have used the IDEA StatiCa software. We appreciated the module beam, where we are able to design and verify the composite structure in very short time. So it was very difficult for us to account time-dependent analysis and effects of pre-stress correctly in a common spreadsheet or software, but IDEA StatiCa can save our time, and it's very beneficial for us. Steel connection. I remember time when we have used spreadsheets for the design of steel connections. It took us a lot of time. It was strange and stressful. And now we can imagine to design the steel bridges in real time without this module. Our wishes to be better are thermal and moving loading in the IDEA StatiCa BIM module, because now these effects are added to the program by hand, so it takes time. The common structure is steel girder and concrete deck composite, so it's very useful for us. Assessment of early thermal cracking in IDEA StatiCa detail module, and some help hints or hyperlinks for better understanding of task inputs and principles of the calculation, to better understanding how the software works. We are trying to explain our junior engineers that software can't replace the engineering craft and experience, that open eyes and engineering judgment are sometimes still our best tool. Ultimately, we are happy to have this strong software to validate or refute our assumption. This allows us to be faster in designing better structures. That's all. Thank you.
Thank you very much for two great presentations. Let's start with a question we had from block 1. It was about engineers checking reports from IDEA StatiCa after someone else. So, how good is the report of IDEA StatiCa? Harri?
I think the report is exactly what the Eurocode is reflecting. If the Eurocode, if we simplify the Eurocode, then the Eurocode is asking for a stress analysis, and then the Eurocode is asking for the resistance against this stress. So resistance for bolts and plates connections, this is completely compliant with the Eurocode, and explaining also what the Eurocode is asking for. And the stress analysis is a finite element model, so that means it's a combination of a beam model and plates, and this is providing just the forces on these connections, and once the forces are known by this model, the resistance could be directly done with the Eurocode. So I don't see there is any problem with the report, because this is basically reflected in the report completely.
Okay. Tomas, your opinion, how good or bad the report is?
I think that the output from IDEA StatiCa is very good. I think it's brilliant if I can compare the different software. So I can do the output for very short time. I can say for just one click, and the output is enough for our clients. And our clients sometimes are very surprised that the output is so detailed.
Okay. Harri, has it ever happened that a proof engineer you have never worked before in Germany saw the report of IDEA StatiCa and said to you?
Yes, so this might happen, because proof engineer system in Germany is very well established, and so if the proofing engineer does not have the same tools, it is very difficult for him to understand, okay, what is it right or wrong? Basically, the proofing engineer only needs to decide, is the structure correct, is the analysis correct or not, or is it providing any danger to the structural system? This is not the case, because everything is listed and provided in the documentation. So Of course, there needs to be discussion if the proof engineer does not have the right tools and does not know how to solve it. But in my experience, once the discussion with the proof engineer was done, it is working.
Okay. And that assumes the report is prepared correctly. That means all your colleagues have to do it. So I'm curious, if you have a junior engineer, Eline, joining your team, how do they, or how they should learn IDEA StatiCa?
Well, first we teach them the general principles, such as fixed or clamped moment connections. Then we give them some tutorials so they get to know the software and all the tricks behind it. And then they get to design the connection. But then we also sit together and we show them how they should input the forces and check if they have done everything all right. So that's how we do it.
Other ideas about how to get juniors up to speed in your companies? Harri?
Yeah, so what we are doing is we are also telling the engineer how the structure could be analyzed manually. So they will recognize very quickly that manually it's a lot of work and it's a very complex work, so it will take a lot of time, but if they want, they can do it once manually, and then they will get a vision of the result. Maybe the result is maybe 10 or 20% different, but they have a view and they can do a plausibility check by themselves.
Okay. Wojciech, in the presentation of Tomas, I saw a lot of detailed checks, something that was maybe previously a little bit overlooked. In your opinion, how much there is of neglected design or over-design in the industry?
Right, so let me answer by the famous engineering quote that the model that you use should be only as difficult as the task you are dealing with. So there's definitely at times some places where you neglect some stuff. But as I said, depends whether it's actually worth it to go that deep into a given problem. So in terms of, for example, concrete, we have customers here doing concrete design. I believe there is still a lot to improve in this regard. I believe that a lot of areas are actually neglected, and that's what we strive to do, enable you to actually check that and check that easily, not to add work to the customers.
Perfect. It's great that I see more questions come in. Keep them coming, but before that, we're going to listen to the third presentation of Eline, and then we'll follow up with the discussion. So let's get into third presentation of this block.
Hi, good afternoon, everybody. I will give a small presentation about SBE, about how we use IDEA StatiCa in our projects and what we would like to see added or improved. So we are an engineering consultancy company which deals with a lot of complex problems in several domains, such as industrial buildings, civil engineering, and many others. I am a project engineer at the steel department, so I get to design steel structures and its connections. And from 2017 onwards, we are also using IDEA StatiCa for our connection design. In this example, which is a new industrial hall for Umicore, we did the design of the trusses with IDEA StatiCa. In dialogue with the steel constructor, a connection with plates at the outer sides of the beam and the diagonal was chosen to facilitate the assembly. So our standardized tables and Excel spreadsheets were no longer sufficient, and we had to search for other ways to check our connection design. This is also an important project to us. It's the new building for the European Medicine Agency. After the Brexit, the EMA had to move from London to Amsterdam, and a new building had to be built. So here we come. So at the ground level, an open floor plan was required, so the columns could not proceed until the foundation level, and trusses had to be foreseen so that they could support the columns. So we did the design of these trusses and the floor beams. For the most connections of the floor beams, the calculations were done by hand, but for the more complex geometries where we had a lot of eccentricities and non-perpendicular connections, IDEA StatiCa was more appropriate. For example, this node where 3 trusses had to be connected to 1 column. We had also several nodes which had a difficult geometry and where the hand calculations were not sufficient. So we recalculated them using IDEA StatiCa and we obtained more efficient results. Also, the stiffness of the connection has a large influence on the forces in the bolts and the stress distribution in the welds, so we could obtain more accurate results. Another project that I would like to discuss is the Oosterweel connection. Around the city of Antwerp, one of the largest infrastructure projects in Belgium is planned, and part of this project consists of building a new tunnel underneath the river the Scheldt, and a deep construction pit had to be constructed for the access ramps to this tunnel. So in order to guarantee the stability of these deep retaining walls, steel frames were added at different levels, which are steel girders that are placed against the retaining walls and steel tubular piles in between. And the normal forces in these tubular piles go up to 35 kilonewton, 1,000 kilonewton, sorry. So at the end walls, these tubular piles arrive at an angle of 45 degrees. So part of the normal force had to be transferred in a shear force in these girders by pure contact. So we add a lot of stiffeners. The other part is transferred as a normal force. Therefore, large steel plates are welded onto the flanges and can serve as a shear key. For the straight tubular piles, shim plates were added, which are the orange plates in the figure. This was both for tolerance reasons as well as to facilitate the removal of the tubular piles, but this implicated a very much reduced contact surface and it complicated the manual calculations, so IDEA StatiCa was used. So we think it's a quite powerful program. We still have some issues in the workflow. For example, when you open old files in newer versions, or when files are opened simultaneously, they can be overwritten. So that's a bit of a problem. We are also looking to further optimize our connection design, and the new feature of the checkbot is helping us, but we are still struggling with the limits of the data size and also its limited flexibility. Of course, we also have some wishes of functionalities that we'd like to see improved. The automatic extraction of forces is already present, but we'd like to have a bit more of control so that we have a lot of members in one node, the calculation time isn't too high. We would also like to see the implementation of surface and line loads. And for the workflow, mostly we model the connections ourselves, but if we have very special geometries, we also use the BIM link. So we think it's great that you're considering new ways of making the construction design more efficient. And that's it. Thank you.
Thanks for another insightful presentation. we discussed junior engineers and how they can what they should do. I'm also thinking, what about the older/senior engineers? How willing are they to learn new methods, Tomas? What's your experience?
Yeah, my colleagues are scared to learn to new methods because it takes a lot of time, and they have no time for the coordination, communication, and design. But I can say that the IDEA StatiCa is a very intuitive software. So I have good experience in our company that my older colleagues are happy, and I can say that they love this software because it's easy for understanding and intuitive, and you can it's very handy. You can design the connection without any knowledge, but I'm recommended to them to look at tutorials and understand how the software works.
And use the engineering judgment, as you rightly point out. Perfect. Eline, your experience with when you're getting other people on board, expanding the team.
Yeah, our company has a quite youthful spirit, so everyone is ready on board. But I think if you show that it's more efficient, they can do their work faster and even more accurate maybe, then I think it's a good idea and they are on board, so.
Wojciech, learning, what's your idea there?
Yeah, I mean, again, I'm going to repeat myself, but if it works, don't break it, I guess. And that's why the velocity we see in adopting new technologies, and didn't want to say the word, but I'm going to say it, BIM adoption, of course, we see it happening for many years now. It's just how the structural engineering industry works, I guess, is the velocity is just not there because safety is the ultimate goal. And if it's safe, if it works, I guess, why change it? So I'm saying the new products actually have to demonstrate the value, which is what we are trying to do.
Perfect. At this panel, we can afford it. We can say that structural engineers are the most important stakeholders in the whole building process, but they have to cooperate and coordinate with other stakeholders. So, Harri, how should the data between structural engineers and others should be interchanged?
So that is a big point, because especially for steel structures, there is now a common view that first there is analytical software where we get the member forces, and then after this it goes completely in a different workflow where people only analyze the connections. And for this data flow, there needs to be a very clear interface for various software packages. So I think that is a demand that this is very easily to be seen, and the PIM model implemented in IDEA is basically providing this, because we can see if we implement the model, what is the element, how the element looks like, what are the forces, what are the adjacent structures. So that means we are not getting an isolated information, we are getting a complete information out of the model. And that is something what is very valuable, because in the past you got paper, and by using paper, 10,000 pieces of paper to find the right paper was not really very easy, and it was very time consuming. So this is a big step forward already.
Okay. Tomas, your experience as a bridge engineer sharing data with others?
I think that the sharing data through the IDEA StatiCa it's very easy. We have no problem with the other company to send them our calculation. It's clear. People can save our internal forces, how the connection looks, how the concrete section looks, how our internal forces. I mean, in IDEA StatiCa Beam. So it's very useful information for the second party. So
Okay.
yeah, we have no problem with this.
Okay. Eline, something you would like to add in terms of BIM from Belgium or Benelux experience?
So our BIM engineers, the ones who make up the plans, often use the BIM, the viewer of IDEA StatiCa, and they think it's quite useful. If they are not able or don't know the program because we don't draw it ourselves, then we use the report where we have all the position of the bolts and thickness of the plates.
Mm-hmm. Thank you. Let's mix it up the question from the audience. Is it possible to use Hilti and Payco libraries in IDEA StatiCa? Wojciech?
Yeah, that's a great question. So the answer is easy. It is not, but we are in talks with those companies, and I'm actually curious if there's somebody interested in using Hilti anchors and helping us develop the product further. Feel free to just show yourself in the chat, and you might be contacted by one of our product owners to experiment with what we've done with Hilti. I'm afraid I can't say anything more on the stream, but if this interests you, then feel free to let us know.
Very good. Very good. Eline, you mentioned how extensively you are using Checkbot. You've mentioned the limits. The limits might mean different values for different people. So what is your desired amount of data that could flow through the Checkbot?
Yeah, sometimes we do have large projects with more than 3,000 to 4,000 load combinations,
Okay.
or like more than 1,500 nodes.
Mm-hmm.
So now it isn't possible, but we hope it's in the future.
Okay. And how much is possible right now, Wojciech?
Right. So I admit, right now, bringing the whole structure into Checkbot is oftentimes a pain, and we are aware of it. It's actually on the top of our priorities because it is conducive to other features that we are planning in the future. So a whole building in Checkbot in minutes, that's the current goal.
Mm-hmm. And if I'm as a user, what is a safe volume that I could work with in number of nodes with the load combinations, as Eline
Right.
mentioned?
At the moment, if you are below 200, you should not see any performance decrease. But yeah, it's not really allowing you to bring the whole building in. It's about
Well,
solving.
it might be the whole building if it is.
If it is a
below
very
200
small
nodes.
building, yes.
Okay. Or we recommend to work with parts of the buildings to.
Exactly.
to go
That's what most of our customers do. That's what we've learned, bringing the most important parts of the building in.
Okay. So you mentioned we are developing. I'm curious if structural engineers should also be developing / coding.
Right.
Harri, what's your idea? Should structural engineers be software developers?
No, I don't think that a structural engineer should do it because it is first challenging, and second, it's only a one-time usage for the structural engineer because it's never a product. It's maybe solving the current issue, but the next current issue is also waiting, and so it's not useful that the structural engineer by himself is developing the software. He should know how the workflow is, and in the workflow he should have the right tool, that there is no need to use Excel or any other software. It's always good if the workflow is inside a few software packages, and this is for the connection design in IDEA StatiCa, basically.
Okay. So structural engineers should not code, but is there somebody in your company who does the coding?
Yeah, we have some software engineers who we can ask to make a little code or even a bigger project if they have time. So yeah, I think it's a nice collaboration if you want to further automate and optimize the workflow. But I do think it's practical if you know some coding, because they don't always have the time to help you directly, and
What is your opinion? What should, especially the bigger companies, should code themselves?
Yeah, we see that as almost essential at the moment, and it doesn't mean there are pure software engineers, but we do see a lot of the low-code, Grasshopper, Dynamo, these visual tools that. Correct me if I'm wrong, but I believe that the main issue is, again, in the cooperation, in bringing data from one app to another in order to speed up the processes. So yeah, I believe having a software engineer on board is beneficial and will be beneficial in the future.
Very good. Is there any plan to implement parametric input? Is that the developer mode, or do you think it's something else?
I think it is both. The developer mode has been introduced, and we are still pushing it because, again, it is conducive to other features that we have on the roadmap for the future. So what is there now with the version 23 is definitely not the end of it, and parametric design, as I mentioned, Grasshopper, those low-code tools to be able to design these complex geometries that the architects are lately coming up with. Yeah, definitely something we will keep an eye on and we will add to the software.
Okay. There is a very trendy question. Will you be integrating AI with IDEA StatiCa? Let me start with either Eline, Harri, or Tomas. What could be the place that the AI should do before we say if you're going to develop or not? In what place of the workflow could potentially AI do something instead of your colleagues?
In assembling information, because what AI basically is doing is pattern matching, and what people are doing when they are searching is basically the same. They are trying for patterns which are already there in the existing workflow or in the existing package of information. So the requirement management could be done by an AI very well. I think requirements management is a very big topic because requirements are never done properly, or they are, if they are done properly, but they are not always described in one location. So to find all the requirements is something what is important for me. And the next point is also for connection design. It's also there to gather the information. If we have a small model that is not needed, but if the model is very complex, the information can be gathered also by the AI very easily.
Other ideas what the AI could do?
I have no idea, but yeah, it could be beneficial, but no idea now. So,
Eline, some?
Yeah, maybe if it could recognize the beam and the forces, and then maybe make a suggestion based on your library that you already have. So then make a suggestion, and then you still can go to the checks and see if it's okay. But
so Wojciech, will we develop something along, or are we already developing something along those lines?
It's a bit embarrassing to admit, but we have been trying that for some time now and still haven't arrived at a conclusion, which is not actually embarrassing. It's the normal process, and we are trying hard to find a place for AI because obviously it is a trend and it is useful. The thing with, and it's been mentioned here with the responses, the thing with structural engineering is that safety is first. And if you've ever tried to use ChatGPT, I don't think you can trust everything it spits out. So I don't think you want AI like that to design your buildings. But in terms of suggesting, analyzing the data, I believe that's where the place for the AI is. And that's where we are trying to integrate it.
Very good, very good. Another question, is it possible to measure something in the viewer? I guess the problem is directly in the 3D scene.
Right. Not at the moment, but makes a lot of sense. So hopefully next time we meet at a Global User Day, it will not be a question for the second block, a voice of the customer, but the first one where we introduced the new features.
So to get dimensions from viewer right now, I have to export it, right?
There are dimensions of the individual plates and bolts, but I understand why somebody would want to measure something more.
Very good.
Yeah.
Last question. Documentation can be a puzzle. Plates, bolts, profiles, welds not annotated in the sketches. And only one view given instead of from side top 3D. So it has arrived. Sketches, drawings. Who is actually generating sketches and sending them around to other colleagues? Eline?
yeah, sometimes we have to do that. If the viewer is of course a handy tool if you want to see some 3D, but you still have to make some sketches. I also import always a 3D model that you have a better look, and maybe add some names of the plates and stuff like that, so that it's more visible which plate is which.
Okay. Waiting improvements in the sketches. What's your idea?
Again, we were perhaps a bit too high on the technology because you see the IFC, you see the possibilities, and you think that that solves it all. But I agree, sometimes a sketch is all you need. And again, yes, improvements to sketches and your 2D PDF output, to put it that way, are most likely coming.
Perfect. Thank you very much for discussing the experience you had with IDEA StatiCa in the industrial workflows. Thanks to everybody for watching the first two blogs of IDEA StatiCa Global User Day 2023.